Hello everyone, welcome to TypeScript Today. Today we're going to talk about these two type parameter definitions and what is the difference between them. The first one is a type parameter that has a constraint, while the second one is a type parameter that has a default type. While these two may seem very similar, they actually do very different things. Let's talk about the type constraint first. What a type constraint will do, it will ensure that T can be only subtypes of the constraint. So for example, we could invoke f with a type that has both foo and some other properties, a subtype of foo. But we couldn't, for example, invoke f with a type that is not a subtype of foo. So for example, a type that doesn't have foo in it. This allows us to limit the possible input values for T, and it also allows us to access certain properties inside the implementation of our generic function. Now let's look at default types. A default type is the type that the parameter type will take if there is no other place to infer the type parameter from. So for example, if we don't pass any parameter to the function, then there is no place to infer T from. There is no place in the argument list to infer it from. But TypeScript will use our default for this type parameter T, so it will use foo. Default parameter types also come into play when we're talking about functions with multiple type parameters where we specify only some of them. TypeScript doesn't do partial inference, so if we specify one of the type parameters, the other one will not get inferred, and it will instead take the default value if one exists, or it will force us to specify the parameter if no default exists. So for example, if we're calling our f2 function with a type argument here of number, then T will actually not get inferred. There will be no inference going on for T. T will just default to foo. What does this mean? Well, it means that we actually can't pass in here a subtype of foo. We need to pass in foo because otherwise excess property checks will kick in. Basically, the type parameter O behaves the same as if it were declared of type foo. So no inference will go on. Now, crucially, the difference between these two, between a type parameter default value and a type constraint, is that the default value imposes no constraint on the type parameter. So while we can invoke it with something that is a foo, we could also invoke it with something that is completely unrelated to foo. So for example, we could call it with any type. So this is the crucial difference between these two. Constraints impose a constraint on the type. You cannot specify any type, while default type parameters only suggest a default value for when no inference can occur. This is the reason why sometimes we actually need to specify both. So for example, let's say we have a function that either allows us to get a subset of the values inside an object O, so specifying them by their key names, and we can take it any key of that object. But if we don't specify an array of keys, then only string keys have to be returned. So for example, for this object O, if we specify no parameters, we should get a return type of just string or number. We shouldn't get bool, which was only associated with the number key. So here we need both of these. We need both the constraint and the default, because if there is no inference, we want to specify something else for the default. Now it must be said that if there is no inference and there is no default, then TypeScript will actually use the constraint as the default. So we only need to specify both of these in cases where they are different, at least for functions. This is of course if we exclude cases where we want to allow the user to specify only some of the type parameters, which probably is not necessarily a common case. So if we don't specify a default, then K will be inferred to the broadest thing it possibly can, namely keys of T, because that is the constraint. But we can also add a default, and the default will be used in this case where no inference can occur for K. So now get values, K will actually be inferred to just foo or bar. The number keys will be excluded because the default was used. Removing the type constraint This function seems to work for the case where we don't specify any parameter, but we notice a problem. Namely, we can't use k to index into t anymore. This is for the simple reason that k is now not constrained to be just one of the keys of t. It could be any type. Indeed, it doesn't even have to be a value that can be a key type. So this is the reason why we can't use it to index. And when we invoke it, we again could pass in here anything. So this is why we need both of them in this case. So again, we can specify both. The constraint ensures that k is only a subset of all types. It can't be any type. It must be a subtype of the constraint. While the default gives us an alternative when inference cannot occur. This discussion also applies to other type parameters, not just those in functions. So for example, if we define a type alias, again we can specify both a constraint and a default. Here the default is more often used because we might want to allow the user to instantiate our type with just some of the type parameters, not all of them. So for example, here we have our getValue type, and if we are instantiating it, we can specify just the type t. We don't have to specify k because it has a default. Now, again, if we don't constrain it, then we actually can't index into t with k because k could indeed be anything. So if we were to instantiate our type, we could pass as k any type. Indeed, it wouldn't even have to be a type that can be a key. If we don't specify the default, if we try to instantiate our type without specifying k, TypeScript will actually error on this. So unlike functions, where if there was no place to infer k from, you could still get away with not having to specify it, here if you're specifying type arguments explicitly, then you have to specify all of them unless they have a default. So I hope this was interesting and you got a better understanding of type constraints versus default types. See you next time.